So we talked about conventional cryptography and public key cryptography. So the question is, when do you use, this conventional is really what we also called as asymmetric key cryptography, and public key is the one that we sometimes call as asymmetric cryptography. The question is, when do we use, the symmetric one, and when do we use the asymmetric one? So the primary point that you need to understand is that conventional cryptography is very fast. Okay, so software implementations can perform encryption. Well, this is a little bit out of date. I think you can probably do many hundreds of megabytes, if not close to a gigabyte these days, because some of these algorithms are like Intel has is a single instruction for doing an AES encryption, and once it is done at that level, then conventional cryptography can handle large volumes of data very fast. Okay. In contrast, public key cryptography is much slower because you are doing these exponentiation operations on very large numbers. Right? So that's why it's quite expensive, and typically it's 100 to 1,000 times slower than conventional cryptography, and this means that you can't use public key cryptography for encrypting large volumes of data. Right? So this is why we always combine the two techniques. So the main advantage of public key cryptography is that key distribution is quite easy, because the public key can be, in a sense, publicly announced, and so the private key is only known to that private person, which means that each person or each principal needs exactly one keypad in order to communicate with anybody. Right? So this is very convenient. So I don't have to worry about large number of keys. Whereas if n people have to communicate using just symmetric cryptography, for n people you need something like n squared keys, because each pair needs a unique key in order to have secure communication between just the two of them. Right? So this means the key generation and distribution is much easier with public keys, but it's no good for doing bulk data encryption. So the way these things are combined is that you're going to use conventional cryptography for bulk data encryption, and but the problem with conventional cryptography is, well, keys, how do you distribute them? This is very difficult, because you need to generate a key, and then both sides of the channel somehow have to have that key. How do you give, if you generate the key, how do you give it to the person that you want to talk to, right? So what is the mechanism for sending that key? So that's where public key cryptography comes in, because you can use public key cryptography to send that key, right? So you can say, oh, I'm going to have a communication. Alice can decide that she wants to communicate with Bob, and she can generate maybe a random symmetric key, and now she can encrypt this symmetric key using public key cryptography to Bob. Okay, so that way public key cryptography basically provides a way to encrypt these secret keys. Okay, and this still leaves one question open, which is how does Alice know Bob's public key, or Bob know Alice's public key? And for that, we need to rely on what are called certification authorities to establish the authenticity of both Alice's and Bob's public keys. Okay, and we'll talk about the certification authorities later on. But this idea and this understanding where conventional cryptography is used and where public key cryptography is used is something that you should really understand very well.